So today's lecture on the double angle formula is for a very specific type of trig equation that you're going to find, which is whenever you have 2 times whatever angle that you're looking for. If you look at example 1, and we're only going to tackle question A, there are actually 2 ways to do it. They say given that theta is in quadrant 3, which is really, really important, because if you're not told that your angle lies in quadrant 3, you don't know what signs your cosine and sine values take. Are they positive or are they negative? So this is a crucial piece of information that we're going to highlight right away. They give you a sine value. They say that sine theta is equal to negative 12 over 13. Find the exact value of sine 2 theta. I'm going to show you both ways to work it. One way is simply by looking at your coordinate plane and setting up a triangle. Okay, so this is way 1. Way number 1. We're going to draw an axis here. We know that it lies in quadrant 3. So we'll draw a little right triangle. In quadrant 3, what are the signs of your cosine and sine functions? Are they both negative? One positive, one negative? Are they both positive? What are the signs? They're both negative, right? They're both negative. Okay. So, your sine theta, if we're looking at this angle, is negative 12 over 13. Well, that's SOHCAHTOA, right? Opposite over hypotenuse. So you have negative 12 over 13. The sign has to be negative. And the sign is the y value, right? So does that make sense that the 12 is negative? Okay. You can simply use Pythagorean theorem or recognize that this is a Pythagorean triple to come up with negative 5 for your cosine. And it makes sense that that's also negative because that's the x component of my triangle. Does that make sense? Okay. Now, to actually evaluate sine 2 theta, you simply look above, and you know that sine 2 theta is equal to 2 sine theta cosine theta. So, in other words, it's going to be equal to 2 times your sine, which we said is negative 12 over 13, and 2 times your cosine, which cosine is ka, so adjacent over hypotenuse, which is negative 5 over 13. So this is 120 over 169. Does that make sense? Way 2 is using a trig identity. Sine squared theta plus cosine squared theta is equal to 1. So let's do way 2. So we're going to set it up. Sine squared theta plus cosine squared theta is equal to 1. Well, you have your sine value. And the reason I use this identity is because I know that sine 2 theta is 2 sine theta cosine theta. So this is just about finding cosine, right? So negative 12 over 13 squared plus cosine squared theta is equal to 1. 144 over 169 plus cosine squared theta is equal to 1. Cosine squared theta is equal to 1 minus 144 over 169, which is 25 over 169. You square root both sides. So cosine theta is equal to plus or minus 5 over 13. But since we know that the theta is in quadrant 3, we choose the negative. Does that make sense? So cosine theta is equal to negative 5 over 13, which we found very quickly right there. And you plug it into your formula again, and you get the same 120 over 169. Do we have questions? So choose the way that makes sense to you. Either one works. This one says if alpha is acute and the cosine of 2 alpha is equal to 3 over 4, find the exact values of cosine alpha and sine alpha. All right, so I'm gonna walk you through this one. If you think you know what to do, you can move ahead of me, that's fine. So I'm gonna start writing my given down, which is cosine 2 alpha is equal to 3/4. All right. Now what I'm going to do is I'm going to work with what I have for my double angle formula for cosine of 2 theta or cosine of 2 alpha, which says, if you scroll up, cosine 2 theta is cosine squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1. Because I'm looking for exact values of cosine, I'm going to use the cosine one. Does that make sense? All right. So cosine 2 alpha is equal to 2 cosine squared alpha minus 1. And then simply you're going to plug in what you know. You know the value of cosine 2 alpha is equal to 3/4. You're going to solve for cosine alpha. You add 1, you get 7/4 is equal to 2 cosine squared alpha. You divide by 2, and you know that 7/8 is equal to cosine squared alpha. You square root, and you get plus or minus. Let's go ahead and simplify this. Cosine alpha is equal to plus or minus square root of 7 over square root of 8, which is 2 root 2. So this is equal to plus or minus square root of 14 over 4. Now we have to decide which one we take. Now the key on deciding if it's plus square root of 14 over 4 or minus square root of 14 over 4 is again on what they tell you in the beginning, that alpha is acute. An acute angle means what? Yes, greater than 0, less than 90 degrees. Well, there's only one place where you have acute angles. What quadrant? The first quadrant, right? And in the first quadrant, what are the signs of your cosine? Are they positive or negative? they're all positive, right? All students take calc. So sine, cosine, and tangent are all positive. Therefore, since alpha is acute, it lies in quadrant 1. And cosine of alpha is equal to positive square root of 14 over 4. Do we have any questions? All right. Finish this one up. Find sine alpha. And then we'll check. You should have gotten sine alpha to be square root of 2 over 4. Did we get that? Negative 1/4 is equal to negative 2 sine squared alpha. Divide by negative 2, you get 1/8. Then you take the square root, you get plus or minus. You rationalize the denominator, you get square root of 2 over 4. You take the positive value because it's an acute angle, which means it's in the first quadrant. I skipped an intermediate step there. Questions on how to do this? Yes, no? Okay. No questions. All right. The ones before that, we needed to find sine and cosine, so we changed our cosine to theta to be either cosine or sine and solved for the corresponding cosine alpha and sine alpha. So, it says simplify using a double angle identity. Simplify means what? If I just asked you to define simplify to a 7th grader, what would you say? Make it more simple. Take it down to its simplest form. If it's a fraction that can be reduced, reduce it until you can't divide anymore, right? Well, when it comes to double angle formulas and things like that with trigonometric functions, simplifying becomes a little tricky because the thought is, where do we end? My response to that is, if it says simplify using a double angle formula, that means you want to get a double angle formula out of whatever it is that you have. And that usually means that when you do that, you'll be able to get it down to, if it's more than one term like B, into one term already. Or like A, where it is one term, a monomial, then you can produce a double angle formula that will help you make the formula more simple to work with. Does that make sense? So, the issue is, it kind of looks like a double angle formula, except what's different about it? Look at your double angle formulas. It's 3 instead of 2, right? So, is there a way I can extract a 2 from a 3? Well, yeah, but you can always take out a 2 and then multiply it by a fraction in order to get 3, right? So, rewrite it. If you make this a 2 sine x cosine x, what would you have to multiply 2 by to get 3? Yeah. So just put a 3 over 2 in front. Well, what is 2 sine x cosine x? What double angle formula is it? Sine 2x, right? So this is really just 3/2 times sine 2x. So we simplified this using a specific double angle identity. Does that make sense? The next one, tricky. It took me more than one try to get this right. But I think you can do it. So give that a try on your own. I want to see where you can go with it. The problem here is that you have a squared. And if you look back in your formulas, you don't have a squared in your formulas. It's 2 cosine, it's 2 cosine squared theta minus 1. But then if you have, you have a 2b. You don't have a theta, right? A 2 beta, sorry, you have a 2 beta. That's the issue, right? We have a 2 beta instead of a theta in there. So Flora's right. The first step, and we'll see if you can get this, you take out a 2, and you have a 2 cosine squared 2 beta minus 1. Now, this looks an awfully lot like 2 cosine squared theta minus 1 is equal to cosine 2 theta.
So we can't write alpha or beta interchangeably.
You can. So what I mean by that is you can say that theta is equal to 2 beta.
Oh.
Right?
Okay.
So you're essentially using a little bit of substitution here. Do you see that?
Yeah.
So what you're saying then is you're saying, okay, well, you have this, which is really close. The only issue is you don't have a 2 theta, you have a 2 beta, where theta should be, right? So if you just use substitution and you say, okay, well, let's just make theta equal to beta, 2 beta, not just beta, 2 beta. Then really, what this boils down to is this equals 2 times cosine of 2 times 2 beta. Does that make sense? Because you said up above that theta is equal to 2 beta. Yeah? You're using substitution right there. And so 2 times 2 beta is 4 beta. So your final answer is 2 cosine 4 beta. Oh, can someone let Michelle in? Thanks. So again, it looked like a simple solution, except we have to be careful what we have in for our angle. We have a 2 beta and not a theta. And because we have a 2 beta and not a theta, we have to use substitution and say, okay, let's make theta equal to 2 beta. Wherever you see a theta, like Flora said, you're going to replace it with a 2 beta. So Flora's right there. You replace that with a 2 beta, that makes your final answer a 2 cosine 4 beta. Questions? Beta, theta? All right. Proofs. Again, like yesterday, if you look, you start with the left side and you naturally derive the right side from the left side. Looking at the right side, you have sine theta plus cosine theta quantity squared. When I see something like that, I think factoring. Okay? They put things together and they put a squared outside. That usually means they factored. Does that make sense? So you're going to have to figure out how to factor. So you have a sine 2 theta. So what does sine 2 theta equal? Yes, 2 sine theta cosine theta. So you've got 1 plus 2 sine theta cosine theta. Well, right now that's not factorable, which means I probably have to change that 1. What can you rewrite 1 as in terms of sines and cosines? It's a trig identity we studied yesterday. Yep. Sine squared theta plus cosine squared theta plus 2 sine theta cosine theta. Yes. Yep. Because really what this is, if you rearrange it, sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. That's really like x squared plus 2xy plus y squared. Well, we know we have, whenever we take x plus y squared, that's what we get, right? So that means, therefore, that we can factor this sine squared theta plus 2 sine theta cosine theta plus cosine squared theta to be sine theta plus cosine theta quantity squared.
Can you like set the sine, like sine theta and cosine theta as like A would be X or Y?
Yeah. Yep. You can do that. Questions? So, strong algebra skills, keep them sharp. Last one, a solving one. My hint for you here, let's look at the problems we've had before. We had a proof. We were able to look at the right side to determine what method to use, so we needed to factor it. The ones before that, we had to force a double angle formula out of it, because that's what the instructions. Now this last one says solve. So we have to find answers within our normal 0 to 2 pi, which is nice. I don't know what that is. And this time, here we go. This time it says cosine 2x is equal to 1 minus 2 sine x. If you have to solve something, you either want it all in sines or all in cosines. So that's what you need to do first, is rewrite cosine 2x as what? What do you think?
1 minus 2 sine.
Yes, 1 minus 2 sine squared x. Then, of course, get everything to one side, set it equal to 0 like we did before, and solve. Then factor. Then set each factor equal to 0. You set that equal to 0, you get sine x equals 0. You set this equal to 0, you get sine x is equal to 1/2. You think on your unit circle, once again, what are all the values for sine that equals 0. Because you are going from 0 to 2 pi, there's no need to add or subtract 2 pi at all. So that's nice and easy. So what are all the values where I have a sign of 0? So 0, where else? Pi, where else? 2 pi. And then what are all the values where I have a sign that's a positive 1/2? That's in between 0 and 2 pi. All students take calc. I have positive sign values here and here. And pi over 6. Where else? Yeah, 5 pi over 6. So if you remember, again, that reference angle, pi over 6, well, which one's this? Well, what do you add to pi over 6 to reduce and get pi? You have to add 5 pi over 6. Questions? Yes. Revision here. So sine x should be 1, not 1/2. Thank you for catching that. Okay, does that make sense though? All right, so let's go back to this interval, because you had to set this equal to 0. So sine x minus 1 is equal to 0. You add 1, you add 1s. Yeah. So on our unit circle, where do we have a sine value of 1? Pi over 2. There we go. That's better. All right. You did it. Survived all the notes. Now you have to survive the exam.